input and robot response. So we might have the whole history then kind of attached to the new user request, right? This is the user input, it's usually short. People are typing something short, but the entire context that's given to the large language model is the combination of the history of what you've been talking about and your most recent statement, and then the agent will produce its next output, the robotic output, right? So this is basically going to continue. It's only 8 billion parameters user request, right? This is the user input, usually short. People are typing something short. We'll see a little bit of system, that orchestration I was talking to you about. We'll see how do we accumulate that chat history to be able to provide that to the large language model. That's actually coded inside of the chatbot you're using or you're familiar with using. You just don't see that, but we're going to go into the internal workings. We'll see how do we accumulate a chat history and turn that into a prompt that we can go ahead and provide to the large language model to come up with the answer. Later, we'll also kind of explore this computed context. We'll get into that a little bit more. But in general, that's the point of the first notebook we're going to go over. What is easy to do? We're going to start with what's easy. It's going to be very easy to give a system prompt and then let the user input, get the response, let the user input, and then by using the history of the chat, right? Instead of saying I can't respond, or according to my context, your name is Sally. We don't want it to respond that way. We want it to just don't mention that you have the context. Just use it as your response. Or I have no name, right? I am created by. I'm not talking about you. I'm talking about what is my name. When the person is talking. This is the answer we want. So this is actually why is this so easy? Why is this so easy to build? And we'll see that in Notebook 1. We're going to see that because that is how the model was trained. The large language model was trained to be those kind of chatbots, right? So the first notebook can also help us define what might be a little bit harder to do. You're going to spot some things in that first notebook. So multiple communication. So this is a good time to take a break from the lecture. And we're going to use Notebook 1. So let me go ahead and flip over to that. So now you can see I have launched. So earlier you asked the question, how much time have I used up in this lab? I've used up 27 minutes. And so far, counting yesterday and today, I've used up 45 minutes. Remember this particular lab, I've given myself 9 hours because I clicked on 9 hours. Can you all see that? I'm just trying to make it bigger. Can you see these numbers? Is that showing up on your screen? Yes. Oh, no. Yeah. It's just this lab, and I probably just going to stop it after 9 hours. But you have like 36 hours. This is the self-paced work. So you're not going to run out of time, but remember you can always ask NVIDIA if you need more time. All right, so let's go ahead and get kick-started. I'm going to get you started with an over-the-shoulder view. So I'm going to click Launch now that the task is started. Notice that the place where I started the task is still there. Still need these buttons later. If I want to step away for a few hours, I should hit the stop. No point wasting GPU time when I'm not going to be doing work. And then later on in the assessment, we'll need this check mark bot that will be preventing cheating. It'll do a second assessment, once inside the notebook, but then once outside the notebook. So let's take a look at our Jupyter Lab environment. So those of you familiar with Jupyter Labs, probably are familiar with this, but we're going to be going over some different models. So right now, I'd like you to spend some time with 1A, basic chat, and then I'll give you some more time to work on 1E, where you'll explore a little bit more deeply some of the things that can be challenging. Let me close this notebook here. I don't need that. Yes. Okay. So you'll be diving deeper into some things that are a little bit trickier. You do not need to go on to the 1T unless you want to. It's just extra exploration. We call it a tangential topic. And instead of using the kind of code that we're interacting with data sets, we'll use a different framework called Crew AI. And Crew AI has you develop agents slightly differently. It kind of defines the agents as members of your crew, and each of them has tasks. So it's less flexible, but it is quicker to build up an agent system. So it does a lot of the grunt work for you. So if you'd like to see how Crew AI works, it might be that your project is well suited to a Crew AI implementation. So I'll leave it to you if you want to explore Notebook 1T. But right now, I want you to go through the basic Chat 1 notebook. I'd like you to go through this notebook. As you know, you can execute each cell. I want you to be aware of what's going on in that cell. So here we're just playing rock, paper, scissors, right? So the output is, let's play a game of rock, paper, scissors. I choose paper. So I'll go ahead and choose rock, right? And it says it's a tie. So it's just very friendly about it, even though he won that one. But so that is its tone. Its tone is to always try and be nice. It's always selecting paper. I selected rock. And then it's so friendly, it says everyone wins. So is this an agent? You know, it's just a bunch of if-then statements, right? So is that really an agent? You know, well, let's think about that. I'm done with this cell. You can see that there's a number there. But later on, we'll have some cells that do some semantic reasoning. And we can go ahead and we're setting up this environment here that will be using a client that is running that Llama 3.1 to 8 billion parameter model. So it's running that small model when you can run on your home computer. And, oh, Randy, I'm sorry, did you have a question? What was your question, Randy?
I'm trying to see, I have the boiling down agents code just as you have there, but you not the machine. I've launched the machine, but how did you, or did you launch that and get a response? Did you run
this cell here? Oh, I'm sorry. You mean when I executed the first cell?
Yes. How did you
just hit the play button?
Oh, okay.
Or shift enter. So as long as I'm in that cell, if I hit shift enter, it executes it. And he chooses paper, and I choose scissors, and it says it's a tie. It always says it's a tie. It's just so friendly. And I can see by the number, Randy, that number 3, it is done executing. Okay? It's kind of tiny. Can you see that?
I can. I have a number 1, which means
it's the first cell you executed in this notebook. This one is the 3rd cell because I executed it earlier, and I went and executed this cell, and then I came back and executed this cell again. So it helps you realize that I executed them out of order. That can help you debug things later on in a Jupyter notebook. Okay? So I went ahead and executed this cell. I'll go ahead and execute it again. It's not going to hurt. So now it says a 4. And I'll execute this cell. And I'm going to basically invoke that large language model. It's taking a little bit of time. See that little star there? I don't know if you see that, Randy. It's kind of tiny. You see the star? It's invoking that. And it's taking some time. And we're waiting for that. So this is, it's waiting for the complete response before, or it's slow, especially since we got 80 people and we're all doing self-paced mode, so things are going to be a little bit slow today. And that cell, I'm not really sure why. Okay, so I did a keyboard interrupt, I didn't wait, but it was taking a long time to respond. Another way a response is to say, don't wait till the last word, because it'll keep producing tokens. The large language model can also do a and putting them onto the screen as they appear in a for loop. So you can see that it is now getting the chunks, and it gives me this response, right? So the system output was blah, blah, blah. And then the confirmation is that system output is their blah, 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 some other stuff like that. So I can have the LLM, I can wait for the LLM to completely respond. That's this single response. For some reason, it took long. Yeah, there it is. That went quickly. So greetings. Here's the full LLM response, and it took 822 milliseconds. Or I can stream it, and so the user hasn't yet here since you've introduced the logo. So it gives you some more text, but it began speaking back to you quicker, even though the total time probably wasn't much different. 308 milliseconds versus 822. So you got your first answer quicker, but the total time might not have been any different. So we can have the large language model. In other words, I don't need to have a chatbot. I can have a program that asks the large language model a question. Okay? So Jeffrey, if you're getting errors, make sure that you executed all of the cells from top to bottom in order. Elizabeth, it may be that your Wi-Fi at home is just slow. Is everybody hearing my voice cut out, or that?
Yes, you're cutting out for everybody.
Okay, all right. I'm going to stop sharing my video. That might help with the throughput there. All right, very good. Okay, so I'm still sharing my screen there. Is that okay? All right. So we can also do that single response, but basically we have a simple request and a simple response. There are layers of abstraction to get this to happen. We have to send a network request to the LLM microservice that was running a fast API router service. We have to make a network request running another fast API service holding a VLLM Triton backend model that we downloaded. That was where our LLM model is running. We're going to insert those inputs into some sort of a prompt template that the LLM was actually trained to use. We're going to tokenize that input into a string of library and the dictionary entries, right? Transformer pre-processing. We're going to embed that into a.
Will my husband enjoy these or not?
I'm sorry. What is this? Somebody have a question? Somebody's got audio going on. Did somebody have a question? Took their microphone off mute?
It was just a hot mic.
Hot mic. Okay, very good. All right. So that's pretty much. We got a crash on there. Sometimes we get that dumping. Might have to try it a couple of times. We're all trying to do this all at once, so there can be some. This is that self-paced mode. I'm not so familiar with it. But if I want to look at those last inputs that went to the LLM, this is pretty much how it's structured as a JSON, a JavaScript object notation model. It basically shows you where the client was located. It had some headers in terms of authentication. There was the user agent. There might have been a billing associated with it. We're basically presenting some messages to the large language model. In the role of user, we are sending the message "Hello World," and we're going ahead and the model was the 8 billion parameter Llama 3.1 model that has a maximum input tokens of 1024, and we wanted the entire answer. So that was the last input that we gave to the large language model. And if we want to look at the last output that the large language model generated, it's also that JSON format. It identifies the chat uniquely. It was a chat completion. It was created at this moment using this model. The role of the model was an assistant, and the content that it produced was this greetings with also this escape characters for single quotes and for character returns. And then it did not produce log probabilities. It just produced the most likely next word. The finished reason was that it reached a stop token. It's not shown here. That says, okay, I'm done responding. So it wasn't that I hit Control C or anything like that. So there was no stop reason. And the input prompts were 17 tokens. It used 274 tokens in its response. And therefore the total tokens, if you're paying the bill at the end of the month for 15 cents for every million tokens, I'd have to add. Is this model thinking? Not exactly, but it's defining, definitely modeling language. It's definitely generating one word at a time. It does look at the semantic space of the context and generates tokens. But does that mean that that model is an agent? Also not exactly. So by default, the model does have various prior assumptions kind of built in, that were built in through training, and they can manifest as sort of an average persona, right? Average way of answering those. After all, the model does generate tokens one after the other, so it is performing actions, right? So that the semantic state of the output will vary and may well collapse a coherent backstory that might get off the rails. But there is no memory mechanism, so the endpoint is essentially stateless. So we can send some requests to see how it works. So we're going to try some different completions. We're going to go ahead and we'll provide a seed. So that's a little bit of a random number generator. When I input the same sentence over and over again, you'll see that sometimes it produces slightly different answers with this experiment here. But if I provide the exact same seed, random seed with this input, and then I provide that seed again, this output here should be identical to this output because I provided that same random number seed to it, right? So that's just be aware that if you're trying to reproduce experiments exactly, you need to make sure you seed that random number generator with always the same value. But then you can see that if I give the same input with the same random number seed, I'll get the same output. But of course, I can structure it differently. What happens when I add an exclamation point? What happens if I spell the words incorrectly, right? So we're trying out some different ones. Hello world. Now we're using a second seed, and you'll see that if I use the same seed, I'm getting exactly that hello B. B, still B. If I use the which one was B and C? I can't remember. B and C are binding to the two different B's. Sorry about that. So we're seeing that by changing the seed, we can get different outputs, and we can also examine different variations of the wording and see the details of what's going on under the hood, right? So we can go ahead and spend a little bit of time with this notebook. I'm getting this error at the end. Okay, so it's trying to get to a model that we did not load. Let me look here. Okay, so we changed the model, but we didn't have that model available to us, so we got that error. So those are just some different things. So what is this exactly good for? Well, it's good for question answering, plus question plus history, giving the answer, or maybe a user request that can give an argument to a function, like what's the SQL database query, or maybe a function selection and a function argument, or maybe a user question plus some computed context. We can give that context guided answer. So maybe when it retrieved that using an SQL function and a particular SQL parameters, it received the response from the database. Maybe I can combine that with the user question to get an answer that not only involves the user question, but also what was provided in the database. So what I'd like you to do now, it's about 11:15. I would like you to spend about 30 minutes going through Notebook 1. And if the time permits, in that 30 minutes, you can go ahead and take a look at the experimenting notebook, where you'll be doing a data set chat. You'll be chatting with some information that is in a data set. So this is a hands-on exercise, kind of following that main lecture in the notebook. The first notebook has a lot of text kind of explaining everything that's going on. The experimental notebook lets you go ahead and play around with different things. So you're still executing it, but it wants you to spend a little bit of time trying out maybe this to-do, maybe trying to figure out how to change the code yourself. So go ahead and play around with that. I'm going to give you 30 minutes right now, so I would like to resume in about 30 minutes. But any questions before we get started? Yeah, Lester.
I'll just go just for my clarification. For the stuff where we're trying the hello world output, so every time it goes through, it's just giving us a random response, right?
Right, but that random number generator is not really random. It's not rolling the dice. It has this random number generator. So if I say generate 3 random numbers, they will be random, right? But if I say use seed number 12 and give me the first 3 random numbers, I'll get exactly the same numbers that if I say start use seed 12 and give me 3 random numbers. That seed determines this basically predictable sequence of random numbers that it generates.
All right, so I was just trying to understand. So the second and third B, right? Its response is like almost the same. Then like after the hello world part, that's where it becomes different. I was just trying to understand what it was doing there.
We're in Notebook 1.
Notebook, we have 1.
And we were looking at the 2 different B outputs, or the 3 different B outputs. And they should be largely identical. I'm not really sure when they're not.
The second B and the third B, they're pretty much the same. Then after hello world, that's where they become different. I would have thought that the second and third B would have been the same, because they're like they got the same seed, whatever, same wording. So I thought those 2 would be the same. But then the second B and the third B are like almost the same after the hello world.
Yeah. So usually changing the seed does change the sampling. So the way that it works, Lester, is that it basically makes a wheel with pie slices proportional to the likelihood that that word is next, right?
Okay.
So the word world, might have a very big likelihood, but the word earth, might have a smaller likelihood. And so then it spins the wheel using its random number generator and picks whatever word that lands on. It's more likely to pick the more likely words, but it still does have kind of a randomness to it, and that has to do with the temperature of the large language model. We can make the temperature 0, ice cold, and that way it only chooses the most likely word. Or we can raise the temperature, that kind of increases a little bit the randomness. Or we can also produce K values, use only the top K possible next tokens, and spin the wheel and pick one that way. So there are some subtleties about how we can tune it, but you'll see that they are subtle, the differences, because all of our questions are within the scope of the training examples that were used to train the models. So we should get fairly consistent. Same seed, same input, same sampling. But the API requires messages. So if we go ahead and give it that kind of a message, we're going ahead and saying that it's handled behind the scenes. You could explicitly say this is the user saying that, but even if you didn't, it knew it was the user because that's handled behind the scenes for Llama's user interface there. So if the inputs are different, that would impact the model, and the sampling would change, even though it's going to be substantial. But if it often sees through misspellings because it was actually trained on real internet, like Reddit posts that have a lot of misspellings. So it's actually pretty good at handling those misspellings. I think that was D, right? So you see that when it got to D, it seems like you attempted to compound not a standard English word. So maybe Hemlo Wordly, please provide details, right? So it's got some things going on in the hood, and that's why under the hood I want you to play around with it, get comfortable with it. Most people are used to using LLMs, using web interfaces or chatbots, but now we're using it inside of our code. So I want you to get a feel for some of the differences that take place. Okay? All right. So I do want you to work on Notebook 1. Just, take your time with it, understand what's going on. You do get errors, sometimes retrying. We have a lot of people trying to access those same servers, running those large language models. They do butt heads every now and then. But read as you go. I think it'll take you about a half hour to go through Notebook 1. So do read the text and understand what you're looking at as you execute the code. And read the code, understand what the code is doing. If you forget how Python works, or maybe you're got some Python, trying to find something that's a little bit difficult. Like, for example, this statement here. What does this statement do? Maybe I forgot what this statement will end up doing, right? So just feel free to go ahead and ask, what is this statement doing, right? So you got your chatbots usually available, and then you'll see that it's a chained assignment, so that the parent roles will be equivalent to writing these three separate commands, but it was kind of written into one single command. Okay, so you can let's say you forgot that in Python. I do that a lot as I'm reading through the code. I just Google what does this Python code do. If I don't remember, is it the teacher goes into roles and the student does, or is it that all three? Those kind of things. So just go ahead and Google it. You can see what the responses are. So what we're going to do is we're going to use this interact function and kind of make a little conversation where we'll have the large language model take on different roles. Maybe you're making a customer service agent. Maybe you're making an engineering assistant agent. Maybe you're making a training agent. You can see that the agents, we may need them to take on different roles. We do that right there inside of the large language model, and then later on we'll learn how to build that scaffolding of the agent around it. All right, so I'm talking a lot, but I'm not letting you play with the notebook, so let's go ahead and play with those notebooks. I would like to return in about a half hour, but I'm seeing that kind of runs into our lunch break. So here's what I'm proposing. Let's take a little bit longer than a half hour and make sure you do get some time with that 1E. Of course, if you're super fast and you want to start looking at that tangential notebook, the Crew AI, you're welcome to do that. But I don't think we're going to stop with the Note 1 notebooks. You asked me, where do you stop? But I do want you to spend about 30 minutes with notebook number 1, maybe a little more time with 1E. If time permits, you're welcome to look at 1T. But I would like to also kind of combine it with a lunch break. So let's say it's a full hour. Is that enough time? Does anybody need more than a full hour to play with these notebooks and also Get yourself some food or coffee or some break stuff. Is that good? All right, thank you, Matthew. All right, so let's go ahead and do that. We're going to work on Notebook 1, Basic Chat. We're going to move on to Notebook 1E, where you get to experiment with a few things. And then, if time permits, you're welcome to look at the tangential Notebook 1T that shows you an entirely different framework to approach the same questions. But that's not required for the assessment. It's just if you'd like to look at it. And I would like to give you a full hour to play with the notebook, but also grab yourself a little bite to eat. I'll be here for the duration, so if you have any questions, feel free to chime in. But I'll go ahead and put that in the chat right now. All right, thank you.
So what is it exactly is it good for? Well, it can probably do some of the following: mapping with sufficient engineering. Use a question, answer, use a question, history, answer. Use a request, function argument. Function argument. And also learn general principles that can help us navigate the broader agent landscape and go up and down the levels of abstraction as need be. Okay.
All right, so we're working on notebooks 1 and 1E. If time permits, go on to 1T. But we're also combining that with our lunch break, so we'll return at 12:30.
As our point of low abstraction. Lowest point of abstraction, and we'll try to limit our course to only the following interfaces. Chat prompt template. This takes a list of messages with variable placeholders on construction. Message this template. On call takes any dictionary of variables and subs and put them into a template. Comes out a list of messages. Chat NVIDIA embedding, NVIDIA read range. Clients that let us connect LLM resources, highly general and can open, connect to OpenAI, NVIDIA NIM versus LLM Hugging Face interface. String output parser and Pandanic output parser takes the response from a chat model, converts it into some other format. Just get the content of the response or create an object. Runnable pass-through, runnable assign. Language change expressed in language runnable interface method to help us construct pipelines. Given resources, we can create a stateful definition of our first LLM power function, a simple system message generator to define the overall behavior and functionality of the model in the context of given instruction interaction. So this is a Python from land chain core prompts import chat prompt template. Takes a list of messages with variable placeholders on construction. We did this. Takes responses of the chat model and converts them into some format. Lane chain chat and video. Connects us to LLM resources. From copy import deep copy. Import copy A equals ML 123 B copy dot copy A C copy dot decopy A.
The life cycle, please. Have you noticed how many bees are buzzing around your garden? Just leave and go. Bees are super important because they help pollinate flowers. But did you know they have a fascinating life cycle? Look at that bee hive. So many bees are working together. They all have different roles, even in community. Let's explore the life cycle of bees.
The life cycle of an ant. Ants are social insects that belong to their family. By social insects, we mean that they live together in large colonies.
In the chat box.